So welcome to our today's lesson where I'll be solving a question which is under blood indices. Okay, so this question is very simple and easy, of course, just follow through. So the question is saying, a 70-year-old man with history of gastrectomy. Okay, so we have to understand. Gastrectomy is just a surgical process where they remove part of the stomach or the lining of the stomach. Then this person presents with generalized weakness. Laboratory testing reveals the following. Okay, so this person went to the hospital. Okay, it is now more like this is the second time of him going to the hospital because it is saying that history of gastrectomy. So meaning at first he went to the hospital and of course he had to underwent gastrectomy. Okay, then now he started feeling some generalized weakness. Then he decided again to go back to the hospital. So the second time now, the doctor decided to do what? To do the testing. And of course, the results were as follows. So these are the results that they got. Okay? These are the laboratory results that they got. So the PCV or the hematocrit was 30%. Hemoglobin concentration was 9.4 grams per deciliter of blood. Then red cell count was 2.4 times 10 to the power 6 per microliter of blood. Okay, so these are the results from the lab. Okay, so now the question here is saying, what condition is he suffering from? Using your calculated mean corpuscular volume. Okay, so here in short, they are indirectly telling us to say you have to find mean corpuscular volume for you to tell us the condition which this person is suffering from, which is about here. Okay, very simple. So what we're going to do here is we're first going to solve for mean corpuscular volume. Then from the results or from the answer that we're going to get, we are going now to tell the condition which this person is suffering from, because mean corpuscular volume tells us about the size of what? Red cells. Okay, the size of the red cells. If they are big, we're going to say it is of course a condition of this. If they are small, of course, we're going to do what? To say of course it is a condition of this. So now let's first try to solve the mean corpuscular volume. So mean corpuscular volume is found by, so we're going to say PCV over red cell count. Okay, so this is the formula that we use whenever we are finding mean corpuscular volume. Then we multiply by 10. Okay, we multiply by 10. So this is the formula. PCV or hematocrit over red cell count times 10. So we have the PCV here because it was there calculated by the doctors in the lab, which is 30%. So we're going to say 30% over then red blood cell count. So red blood cell count, we have 2.4 times 10 to the power 6 per microliter of blood. So we're going to say 2.4, okay. Then times 10. Okay. So now, here, if we substitute and we solve this, or we can say times 10 to the power 6 there's no problem. We can say that here. So, if you solve this, if you calculate this, so let's just maybe try to get it together. So if it's a 30 divided by 2.4 times 10 to the power negative or to the power positive 6. Okay. So then times 10 again. Okay. 30. So I'm getting 125. Okay. So here I'm getting 1.125. So this 125 that I'm getting here, 125, it is now in what units? Okay. It is in femtoliters. Okay. So this is 125 femtoliters. So now for us to tell, because we have calculated the mean corpuscular volume, that they told us like indirect to solve it. Okay, we have it here, 125 femtoliters. So now for us to tell what condition this person is suffering from, we have to know the normal ranges of this mean corpuscular volume in an average person. Okay, so the normal range of mean corpuscular volume in every or in average person is supposed to be 78 at least to 90 femtoliters. Okay, this should be the range. It should be between these from 78 to 90. If it is above, then it is abnormal. Okay, so and this one it is above because it is 125 instead of it being between 78 and 90. So we are concluding to say, because of this value that we have gotten, this person is suffering from which condition? At first, in my preamble, I said that the mean corpuscular volume tells us about the size of what? The cells, the red cells. Okay. So now, here we are having 125. So meaning this is like higher than normal. So meaning the cells are what? Larger than normal. Okay. So this should be, or it is termed as macrocytic. Okay, macro meaning they are big, the cells they are big. Then cytic, we are talking about their size. Okay, so it is big-sided cells. Okay, macrocytic, they are big size. This is macrocytic anemia. So this is macrocytic anemia or pernicious anemia. Okay, so this is the condition that this person is suffering from. So we have answered this question. What condition is he suffering from? Using your calculated mean compensated volume. So at first, we were told indirectly to solve for what? For mean compensated volume, which we have. Okay, and of course, now, what condition is he suffering from? Well, of course, solved. It is what? Macrocytic anemia. Now, what if they had to ask us, what is the reason for your answer? Okay, we have to tell. Because, check out, in the question, they were saying that this man who is 70 years had an history of gastrectomy, and when we're talking about gastrectomy, they're going to remove part of the stomach, and there in the part of the stomach we have got some cells that produce intrinsic factors. Okay, when they produce those intrinsic factors they're going to help now in absorption of what? Vitamin B12. Okay, so vitamin B12 gets to be absorbed by the cells inside our body by the help of what? Intrinsic factors. And those intrinsic factors are produced by what? By the stem cells which are found in the lining of the stomach. Now, here we had an issue because it was removed by gastrectomy. So no wonder this person is having what? Macrocytic anemia. Okay? Because vitamin B12 was not being absorbed by the body because of shortage of what? Intrinsic factors. Because of gastrectomy. Okay, so this is how we get to answer this question. So now, how can we solve using these? How can we solve the other two? Okay, so now I'm going to give you a mnemonic how to solve them. It's very simple. So to start with, let's first try to solve, okay, we solve first the mean corpuscular hemoglobin. So mean corpuscular hemoglobin will be equal to, so as long as it is mean corpuscular hemoglobin, we are going to solve for, here it is hemoglobin concentration, okay? Hemoglobin concentration on top over the cell, red blood cell count, okay? Okay, let me just use this one. Red blood cell count, okay, like that. And of course, multiplied by the same factor, 10, multiplied by 10. So this is how we get to solve what? The mean corpuscular hemoglobin concentration, or rather just hemoglobin. But if we were told maybe to solve for mean corpuscular hemoglobin concentration, so whenever we're solving for mean corpuscular hemoglobin, then concentration, the formula changes. We're going to say, okay, the formula gets to change. So here we're going to say, since we are having two C's in the formula, we have this C and this C, mean corpuscular hemoglobin concentration. So meaning, even in our formula, we're going to have two of things, okay? All the things that we're going to be putting in the formula, they're going to be two. We're going to understand it. So what I'm saying is this, mean corpuscular hemoglobin concentration will be equal to hemoglobin, of course, here, hemoglobin concentration over here, instead of us putting a red blood cell count, we're going to put what? Hematocrit, okay? Hematocrit. So now, hematocrit is having H, even here we're having what? H, so 2H, have you seen 2H? So now, multiplied by what factor? Because we're having two C's here, and we're going to be having two things in the formula, we're going to multiply by 100, meaning 2 zeros, okay? 2 zeros. So we're going to multiply by 100. So this is how we get to solve for mean corpuscular hemoglobin concentration. Hemoglobin concentration over hematocrit or PCV. Okay, hematocrit is the same as PCV. So hematocrit times 100. Then this one, mean corpuscular hemoglobin, because we're just having one C, everything is 1. Hemoglobin over red blood cell count times 10, 1 0, and of course 1 H here. Okay, very simple. So now, we also have to know the normal ranges of these. What are the normal values of these? So for mean corpuscular hemoglobin, okay, it is measured in picograms. So this one is measured in picograms, and the normal range of this one, it is of course, it should be smaller than this one because it is having just one C in the formula. Okay, so this is how we get to solve it. It is having one C there. It is going to be from 27 up to somewhere 32, okay, picograms. Now, what of mean corpuscular hemoglobin concentration? Okay, so this should be from 30 to what? 38. This should be from 30 to what? To 38. 38 what? So this is now grams per deciliter of blood. Okay, grams per deciliter of blood. So this is how we get to solve. So if maybe we're like asked a question how to solve for mean corpuscular volume, or rather mean corpuscular hemoglobin or mean corpuscular hemoglobin concentration, would have used this formula, and of course would have used these same normal ranges or normal values that we have here. But this is how we get to solve this question.